How's it going, everybody? In this video, we're going to go ahead and take a look at the problem statement that VLANs and trunking injects into an environment when we're talking about MAC address propagation. So in a typical campus area network, you're going to have switches that support VLANs and trunking, unless you're doing some sort of whiz-bang wow feature like DNA Center or something like that. For the most part, we're going to just be dealing with normal layer 2 networking, right? VLANs, trunking, spanning tree protocol, MAC address propagation in the data plane. Well, that's all well and great. As long as you don't have a ton of layer 2 communication going on inside of the same broadcast domain, the MAC address tables are usually not terribly large. However, if you try to inject the VLAN and trunking logic into a data center that connects to where the access layer switches connect down to a large number of MAC addresses being generated, whether it's through virtual machines or some other scenario, you're going to have lots of MAC address propagation. So I've seen the good and bad designs out there, and I'll give you a classic example of what not to do. In a data center, you don't want to use campus LAN solutions at all, right? They're not designed to be used in the data center. Data centers need more scale out options, east-west communication, and obviously north-south. The problem with using typical campus LAN solutions in a data center is the fact that wherever that layer 2 VLAN exists and wherever there's trunking between switches to propagate those MAC addresses and to tag them appropriately so that they land in the right VLANs, wherever that VLAN sits, so do MAC addresses in that VLAN. Because Ethernet by default is a flood and learn, keep bumping my desk here. Ethernet is a flood and learn style technology, right? So when a MAC address is learned inbound on any port in a VLAN, it is going to be propagated to any other switches that are connected to that switch that also host that VLAN. So if you have a very large, a lot of switches with one VLAN deployed on it, every switch is going to learn that MAC address wherever that VLAN exists. It doesn't matter how big it is. It could sprawl across the WAN if you wanted to go that far with it. And that's not a good idea, because then you run into resource utilization, so on and so forth. Another reason why you don't want to use VLANs and trunks in a data center is because typically you're going to have a lot of segmentation, meaning lots and lots of VLANs. Normally your campus layer switches are going to have an upper limit of how many VLANs that they can support. There was a customer that I worked with a few years ago. They decided, the engineering team had deployed VLANs and trunking as a solution before I ever showed up as a consultant, and then eventually I did my best to try to explain to the customer, and it brought in multiple other resources as well to try to explain it, to not do that. So essentially what ended up happening was VLANs and trunking were used and spanning tree protocol was brought into play. The problem was that they were using typical access layer switches because they were cheaper, $1,000, $1,500 per switch, depending on what eBay vendor this particular customer got them from. Well, the problem with this design is that every switch was running VTP, VLAN trunking protocol. So if you went to the VTP server, whatever switch that might be, and then you created VLAN 27, for example, every customer had its own VLAN for segmentation. You'd have to create an SPI on the switches, and typically you're going to deploy HSRP for gateway redundancy in that particular data center. The problem with that, though, was that means that all of your distribution switches, which means there were 3 different data centers that this particular customer maintained. They had distribution switches, 2 distribution switches per data center, and then they had multiple access layer switches per data center. That means that if the VLAN got created on one distributed switch, or one distribution layer switch, in DC1, that VLAN was propagated to DC2 and DC3 and all the access layer switches as well, because between the data centers or distribution switches deployed, and all the distribution switches were interconnected with each other via trunking. So if a MAC address in data center 1 was learned, it would be reachable in data center 3 across the layer 2 backbone, because everything was layer 2 adjacent. Think of it just one big layer 2 backbone. There were lots of VLANs, so they were doing segmentation, but they just didn't scale well. So once you cross the 100 or so VLANs, the switches that we were dealing with on a regular basis didn't have weren't built to do that. So on a regular basis, you would see 70, 80, 90% CPU. And God forbid if there's a storm, broadcast storm or some sort of broadcast or flooding event in the environment, that would literally bring the network to its knees. And we'd have to start yanking cables to try to bring down the connectivity so that we would eliminate the problems that we were running into. So that brings into the case, well, what solutions might you use spanning tree wise in order to mitigate that? Well, commonly what I would tell the customer, I tell this to a lot of customers that are running layer 2 networking that need it, that can't move away from that, is only deploy the VLANs and the switches that you need. Don't deploy every VLAN to every switch, right? If you know that customers are going to be plugging into specific switches and specific data centers and specific cabinets, only deploy the VLANs to those specific switches that are necessary. Don't deploy that VLAN everywhere, because that's going to allow the MAC address propagation to go everywhere. You're going to have a trunk link from the distribution layer switch down to your access layer switch. Use trunk allowed commands on the downstream connections from the distribution down to the access, and only allow whatever VLANs are allowed on that access layer switch to be allowed to be propagated down from the distribution switch to the access. Some very simple layer 2 spanning tree capabilities to try to control the layer 2 propagation. Is this an administrative overhead, an administrative burden? 100%. And that was the main issue that we ran into. Because if you've got the ability, and this particular customer had virtual private servers, meaning that a customer could go literally buy a server from that particular data center provider and have that particular server plugged into the environment, and it might be running VMware. It might have 100 VMs on it. You get 100 VMs, that's 100 MAC addresses, right? And if that's one specific VLAN for that particular customer, then you're going to be learning 100 MAC addresses on that switch, and then every other distribution switch is going to have to learn those MAC addresses. There were a couple of times where we saw MAC addresses or MAC address tables physically maxed out. In other words, on the distribution layer switch, there were a couple of times where, in the event that a Cisco Catalyst-based switch ends up learning more MAC addresses than the switch can support, it turns into a hub. There's no longer any intelligent switching from one port to the other, right? Mapping this specific MAC to this specific port so that you can control the data going back and forth. That feature and capability went right out the window when that was deployed. So there were a couple of times where we literally would see CPUs spike on the switch and just flooding everywhere. And that wasn't because the customer was doing anything wrong. It wasn't because there was, well, it was, at the end of the day, it comes down to the way the data center was built, right? The logical configurations that were put on the boxes. And numerous times, myself and a couple of other engineers tried to work with the data center folks to try to move away from that. Let's deploy VXLAN. Let's try to deploy some other solution to mitigate that. There was a number of other things that were wrong in the environment. So this is probably the worst deployed environment that I had ever worked in. And I worked pretty continuously for a period of time to try to mitigate a lot of the issues that were going on. The problem that I ran into, and the reason why I'm going into some level of detail here, is what not to do, right? I got a lot of pushback from the environment where the ownership of this particular data center didn't want to make a lot of changes for whatever reason. They didn't. I was never really given any good justification. It was just, we're not going to do that. But I was expected to make the current environment work and be highly available whenever there was whenever possible, and if there was a problem, that I should be reachable via phone to fix whatever problems might crop up. It was asking a lot, but not giving a lot back. So that customer ended up being very difficult to work with. And there will be customers that you guys will all work with that'll be very difficult to work with as well. Now, the bottom line here is not just to throw shade at this particular customer, and I'm not going to give you any indication of who this customer might be. They're anonymous as far as you guys are concerned. The problem still exists today. As a matter of fact, I personally know people that still work at this organization, and the existing environment that I struggled with 3, 4, 5 years ago still exists today. So, and there doesn't seem like there's going to be any change in the environment anytime soon. So that is the case. So because of that, I felt like this would be a great time to break down why having lots and lots of MAC addresses would be a bad thing. So what we're going to do is I'm going to switch gears over to the environment. We're going to deploy VLANs and trunking. I'm going to deploy a single VLAN, and all the connections in between the switches are going to be configured as trunk links. Even though there is IP addressing, there'll be trunk links. And we're going to get a couple of PCs, specifically VLAN 10 for customer 1. We're going to go ahead and generate some IP addresses, and that'll build the MAC address tables. And so we'll see traditional layer 2 networking and go from there. So let's go ahead and take a look at this config. I'm actually going to go ahead and bring this over. So I'm going to go ahead and bring this down just a little bit. And what we're going to do essentially is on 9K1, 9K3, spine 1, and spine 2, what we're going to do is we're going to configure VLAN 10 for PC 13, 14, and 20. We're going to get them joined, and we're going to generate some pings back and forth to make sure all this stuff is going to work. So to start this bad boy off, I'm going to go admin and admin. I'm going to go to global config. Host name is going to be 9K1. And I'm going to go ahead and say VLAN 10. Name is going to be VLAN 10. I'm going to go ahead and exit out, and I'm going to say interface, and that's going to be E1/9, E1/9, switch port, mode of access, switch port access VLAN 10, spanning tree port type edge. Okay, so spanning tree protocol is going to kick in for that, and it's going to make it basically a port fast port. I'm going to go to interface E1/1 through 2. I'm going to say switch port. I'm going to type in switch port mode of trunk. Very, very simple command there. And then I'm basically going to go ahead and do the same thing everywhere else. So let's go ahead and do Nexus 9K3. Log into him real quick. Sorry, I changed the password on this guy. There we go. Go to global config. Host name is going to be N9K3. We're going to say VLAN 10. Name is going to be VLAN 10. Whoops. VLAN 10. Interface, in this case here, will be 1/7 and 8. So interface E1/7 and 8. Switch port mode of access. Switch port access VLAN 10. Spanning tree port type edge. Why did I get an error? I have no idea why I'm getting an error. Huh. Let me refresh. Sometimes that happens. Okay, that was a little weird, but okay. Alright, so there we have that. And then we're going to type in interface E1/1 through 2, switch port mode of trunk, and there we go. Now I'm going to go to spine 1. I'm going to go ahead and log into spine 1 real quick. And all I'm going to do here is host name is going to be spine. Host name is going to be spine 1. And then we're going to say interface E1/1 through 4. We're just going to come in here and say switch port mode of trunk. And then we're going to go and say VLAN 10. Name VLAN 10. There we go. Same thing as spine 2. admin and admin. We're going to go to global config. We're going to do host name is going to be spine2, VLAN 10, name is going to be VLAN 10, and then interface E1/1 through 4, switch port, mode of trunk. Alright, with that being configured now, what I should be able to do is go back over here to PC 13, 14, and 20. On this guy here, we're going to do a show IP, and I don't have an IP address configured yet. So I'm going to say IP address is going to be 10.1.10.13/24 and hit the enter key. And then a 10.1.10.254 invalid IP. What is the command that I'm missing? IP. Oh, okay. My mistake. Get rid of the IP address piece. Just the IP. There we go. And I'm basically just going to take this command over to 14 and 20 respectively. And 20 lights, just like that. Okay, cool. Now, because the ports, so let's just make sure on the ports that we're good to go here. We're going to do a show interface status. Make sure that the ports are currently up and running. We're looking at 1/9. 1/9 is connected and working. Okay, perfect. Now, the cool thing about this is if I try to go and ping, so I'm actually going to go ahead and scoot this up a little bit. One of the things that I'm going to go ahead and do is I am going to right click here on 9K1. I'm going to go to capture on E1/1. Okay, so let me go ahead and log out. Sometimes this happens and I have to log back in. Make sure you set it to native console. I'm going to go ahead and log in as admin and Eve real quick. Try that one more time. I'm going to go ahead and right click here, capture E1/1. Okay, so we're getting an issue with that. Not sure why that's giving us a. I may have to reboot the. It's a middleware issue. Okay, so I wanted to show the encapsulation, but that's okay. I'm sure you. So if we were to do a show system internal L2 forwarder MAC, you're going to see some MAC address propagation happening. So one of the things that I want you to pay attention to with how this is working is that we're going to receive some communication inbound from stuff, right? We're going to see VLAN 10 dynamically learned. So to justify some of this stuff, we come over here and we do a show IP. You're going to see a 680D, and on here we're going to see a 680D. On switch PC 14, show IP, we're going to see a 680E, and guess what? We're going to see a 680E. And on PC 20, we're going to do a show IP, and we're going to get a 6814. And if we look at Nexus 9K1, we see 6814. So essentially what's happening here is we have the flood and learn style of Ethernet is working, right? Now we go up here to Spine 1, and I jump out of global config, and I do a show system internal L2 forwarder MAC address. You can see the same thing happening here, right? 0D, 0E, 14. Now, there's nothing wrong with that, right? Everything's working quite well with the deployment that we have currently set up. But if this was to scale out, right? If I was to be in a situation where I had hundreds of PCs, right? And hundreds of VLANs, which was 100% possible. There were, the environment that I was just talking about, there were more cases where we had a customer deploy ESXi or some other type of virtualization software, and they would deploy VMs. And they would deploy lots of VMs because they needed to do whatever it is that they were doing, because our goal as a data center was to provide them a endpoint or the ability of getting their solution to work. We didn't really care what they did as long as they were paying our bill. We didn't really care. So when that happens and you get lots of MAC addresses being generated, the endpoints, the access layer switches have to learn that. As you can see, no matter where we point, every one of the switches has to learn every one of the MAC addresses in that particular VLAN. Now, in most cases, no harm, no foul, right? But in a large environment where you've got potentially lots of customers, and customer A may only have a few MAC addresses and they only might work a couple of hours each day, but then you have a customer B might have 200 devices that they need to communicate back and forth with, and that scales, and they're attached to a lot of different stuff. The amount of MAC addresses that can be learned per switch, it's not that many. We're not talking hundreds of millions. We're talking a couple of thousand. And because the amount of memory that's available per box just isn't there. So this is the problem statement that comes into play with using VLANs and trunking. So I'm not going to go into much more than that, because if you don't understand how VLANs and trunking work up to at this point in time, that's going to be something that you need to go back to basic CCNA prep and make sure you understand what a VLAN is and what a trunk is. You kind of need to know that stuff before you get to here. Now, with that being said, let's actually try pinging in the data plane. So we're going to go ahead and ping 10.1.10.14. And I can ping it, right? Everything's working out the way that it's supposed to. And if I was to hit the up arrow and ping 20, I should be able to ping 20 as well. And I can. That's the beauty of a solution like this, right? Because it allows me to deploy and meet the need. Now, because I have this capability in play, if I was to add more MAC addresses, like for example, if I was to add, let's go ahead and just add on 9K5. Let's go ahead and log into 9K5. And this is where this process comes into play that I want everybody to understand. If I do a interface E1/1 through 2 and type in switch port mode of trunk, right? And then I go ahead and say host name is going to be Nexus 9K5. And let me create VLAN. So let's do a show system. So for anyone that's curious, show MAC address table dynamic. MAC address table dynamic. It doesn't work here. So we do show system internal L2 forwarder MAC, and you can't define the MAC, but if you were to say come in here and do a pipe and include 10, obviously you wouldn't see anything. But if I was to create VLAN 10 and say name VLAN 10, because we're going to have VLAN 10 on here anyway, and do that same command again, what's eventually going to end up happening, if I was to pull this stuff out, as soon as I send traffic down to, let's actually show interface status real quick. Okay, so show VLAN brief. It's active. Okay, so it might have just taken show spanning tree for VLAN 10. Okay, so it was in the process of figuring it out. So if I was to ping again from 13, go back to 5, what should end up happening is, I'm not sure why we're not learning any, but, oh, that's, did I? Show interface trunk. Let's make sure that all the ports are, well, they're allowed on all the ports, which is weird. So I should be learning MAC addresses down here on 5, which I'm not, but I should be. But the point that I was trying to make was by having the MAC addresses flood down here, what should end up happening is we're learning, and there's no endpoints attached to VLAN to 9K5, right? But what would end up happening is you would get MAC addresses being learned downstream on 5 and 6. If they've got VLAN 10 created, there's no need for them to learn any MAC addresses. There's no endpoints in this area that are configured for VLAN 10, so therefore VLAN 10 shouldn't be needed. So things like that do need to be taken into consideration. So long story short, when you're taking a look at how typical layer 2 networking works with VLANs and trunking, if you are forced into a situation where you have to deploy VLANs and trunks in order to do the job, fine. go right ahead. But make sure you're being cognizant of where your flooding domain is going to sit. If you have the ability of working with a scalable architecture with distribution and access, make sure that your distribution switches are configured to only propagate down to the access layer switches the MAC addresses that are needed. Because you may be in a situation where your access layer switches, access layer switch 1, 2, and 3 might have the same VLANs, but 4, 5, and 6 do not. But if you're using VTP, VLAN trunking protocol, to propagate VLANs automatically, so that you don't have to go to each individual device and create them if they're already there, that's something that you could potentially want to pay attention to and make sure that you're mitigating before it becomes a problem. Because if you're propagating MACs for the sake of propagating MACs, that's where the problem becomes a real issue. So keep those things in mind when you're playing around with your networking, and make sure that you understand what it is you're getting yourself into. So words for the wise. Okay, at least that's my end goal. With that being said, ladies and gentlemen, in the next video, we're going to transition over to VXLAN. I'm gonna go to routed ports. So I'm basically gonna go ahead and I'm going to configure all of these interfaces on all these devices to be routed interfaces. We're going to go ahead and IP address them, and then we're going to turn OSPF on a point-to-point nature. So we'll have a very, very optimized backbone in that particular case. And then we're going to go ahead and deploy the solution with VXLAN in the video after that. But I wanted to make sure that I was very clear as to what the problem statement is with VXLAN. Until next time, guys, thanks so much for stopping by and hanging out with me. And I will catch all of you in the next video.